Welcome, recruits, to Phase 8.1 of AP Calculus Bootcamp. Operation Applied Integration. Your clearance is verified for recruit eyes only. Today's operation covers topics 8.1 through 8.6, representing a massive 10 to 15% of your AP Calculus AB exam. Status: Mission Go. Here is your sitrep and mission objectives. We are deploying integration to solve physical and geometric challenges. Objective 1 is tracking accumulation, monitoring baselines, calculating net change, and tracking particle motion. Objective 2 is securing the area of operations, calculating 2D territorial boundaries using dx or dy protocols. Objective 3 is complex territories, executing multi-stage maneuvers for boundaries with multiple intersections. Threat level high. The average pitfall. You must not confuse these two distinct mission directives, as deploying the wrong protocol guarantees mission failure. The average rate of change from Unit 2 requires an algebraic override, the slope of the secant line. However, finding the average value of a function requires the calculus protocol, the definite integral. For topic 8.1, we deploy the average value leveler. First, execute the accumulation phase by finding the total definite integral from a to b. Then, execute the leveling phase by dividing by the base width, b minus a. The resulting average value is the exact height the function would be if all its accumulation were perfectly leveled across the interval. Tactical distinction. Motion protocols. When tracking a target, you must distinguish between displacement and total distance. Displacement is the net position change found by simply integrating velocity. This allows negative backward movement to cancel positive forward movement. Total distance is the total odometer reading. This mandates the deployment of absolute value brackets around the velocity function, neutralizing negative direction and forcing all movement to add up. Secondary protocol. The accumulation form. When tracking current position x of t, you take the initial coordinate, where the target started, and add the net displacement, the integral of velocity from the start time to the current time. This is a highly effective maneuver when an explicit antiderivative is impossible to extract, but calculator technology is authorized. Intel decryption for topic 8.3 translation. You must parse raw verbal intel into mathematical syntax. If the unclassified signal asks for total visitors based on a rate of entry, recognize that integrating a rate of change always yields the net change of that quantity. Deploy the integral of big R of t dt from a to b to secure the confirmed identity. Phase 3 briefing. Securing area of operations. Do not memorize long lists of area formulas. Area problems are limiting cases of Riemann sums, adding up an infinite number of infinitely thin rectangle areas. Your objective is simply to identify the boundaries of a single representative slice, height times width, to unlock the entire territory. The definite integral handles the infinite addition. To set up your rectangles, consult the thickness decision tree. Draw a representative slice. If the slice is vertical, the thickness lies on the x-axis. You must deploy the dx protocol, and all equations and bounds must be in terms of x. If the slice is horizontal, the thickness lies on the y-axis. You must deploy the dy protocol, and all equations and bounds must be in terms of y. Orientation is law. Executing the dx protocol for topic 8.4. When thickness is dx, we scan the territory from left to right. The boundaries a and b are strictly x-coordinates. The vertical slice height is defined by the top curve minus the bottom curve. Your mathematical directive is the integral from a to b of f of x minus g of x. Executing the dy protocol for topic 8.5. When thickness is dy, we scan the territory from bottom to top. The boundaries c and d are strictly y-coordinates. The horizontal slice width is defined by the right curve minus the left curve. Your mathematical directive is the integral from c to d of f of y minus g of y. Threat level critical. Complex area of operations. If multiple intersections are detected, a single integral is insufficient because the top and bottom functions switch positions. You must execute a three-step action plan. 1. Locate the intersection points. 2. Split the territory at the intersection. 3. Sum the intel by setting up two separate definite integrals, applying the top-bottom protocol independently to each zone. Mandatory rules of engagement for FRQ setup protocols. A correct final answer without proper mathematical setup may yield exactly 0 intel points on the AP exam. Do not perform calculations in your head. You must explicitly write the integral sign and limits, the integrand expression, and the differential dx or dy, using the correct notation and not calculator notation. Time for the after-action report. Phase 8.1 through 8.6, debrief. 1. Average value requires the integration leveler formula. 2. Total distance mandates the deployment of absolute value brackets. 3. Orientation is law. Your representative slice dictates dx or dy. 4. Split complex territories at intersections. You are now prepped for Phase 8.2, Volume Applications. Status: dismissed. For more AP Calculus worked out free response question solutions, like and subscribe to get your FRQ on.